Hi folks, this is number 8 from the Unit 7 review assignment. So let's see what's going on here. So Brett is jumping on a trampoline in his backyard. Each jump takes about 2 seconds from beginning to end. He passes his bedroom window, which is 4 meters high, 0.4 seconds into the jump. Okay, and create a quadratic relation to model Brett's height. Okay, so let's take a look at what our variables are. We've got height with respect to time, and then use it to determine the maximum height. Okay, so as I often suggest, I'm going to draw a diagram here. So we have somebody on the trampoline and going up, and over time eventually comes back down. Okay, but what I want to do is I want to put this on a Cartesian plane. So I'll assume that the start of the jump is going to be at time 0. So we'll say this is height and this is time. Okay, so at time 0, and it takes 2 seconds to complete a jump. So this is when I realize that I actually have the x-intercepts of this function. So I can very easily start writing my model. H is equal to, well, what I'm missing is the a value, times t minus, well, the first x-intercept is 0, and the second x-intercept is 2, so t minus 2. So in other words, I know my equation will look like this, a times t minus 2. Of course, what I'm missing is the a value. And so this is why they had to give us some other piece of information. So at 0.4 seconds, so somewhere here, the height is going to be 4 meters. So all I'm going to do is input this point into the function to find the a value. So when the height is 4, okay, the time is equal to 0.4. Okay, so let's use that to calculate the a value. Okay, so here 0.4 minus 2, okay, times 0.4. All right, and then I'm going to do 4 divided by that answer. So 4 divided by the answer, and it's negative 6.25. Okay, so had I gotten a positive number, I would have known that I would made a mistake, because obviously this should be facing downwards. So now that I have the function, h is equal to negative 6.25 t times t minus 2, I just have to find the maximum height. Okay, so there's a couple of ways I can do this. I can multiply this out, put it in standard form. I could either use negative b over 2a, or I could complete the square. But here I can see, even right off my diagram, that I know the x-intercepts, and I know the x value of the vertex lies between the two x-intercepts, in other words, at 1. So I already know that the x value of the vertex is equal to 1. So if I want to find the maximum height, all I have to do is input the x value of the vertex into my equation. Okay, so here I avoided having to do all that other work of distributing and either completing the square or using negative b over 2a. Okay, so negative 6.25 times 1 minus 2. But I realize that this is just equal to negative 1. So negative 6.25 times 1 times negative 1 is just positive 6.25 meters. So that's the maximum height. All right, so just to recap this problem here, so really the big trick was getting the equation. So remembering that, if I know the x-intercepts, I can write the equation in factored form. The only thing that's left to do is solve for the a value, which is where I use the other information given. Okay, and of course was to realize that 0 and 2 were the x-intercepts. That was much easier to do when I drew a diagram. Okay, that's it for this one.